Hello, everyone. Thank you for joining us. Today, I'm sitting in with Brian Kanonchik, Director of Innovative Digital Technologies at Boston Engineering, who will be walking us through an introduction to augmented reality. We'll touch on some technology overview along with some practical use cases in the enterprise space with examples along the way. In addition, we have a QR code that you'll be able to scan to participate in a live AR demo with us. And to get us started, Brian, how would you describe augmented reality?
Yeah, great question. And augmented reality is one of these things, and it's a very fascinating topic because in the industry, it's one of those things that hasn't changed a lot at all, but at the same time, it's changing rapidly. Even though all the use cases we're seeing are very standardized right now, nothing new and cutting edge, the hardware is just improving immensely. Back to your question, what is augmented reality? Augmented reality at its core is really just an enhanced version of reality itself, viewed through a lens. That lens being the lens of your iPhone, the lens of a HoloLens, the lens of a Magic Leap, the lens of a Vuzix. And what you're viewing through that lens is 3D digital content placed in that physical world. So we're using 3D to enhance our reality through the lens of any type of supported device. With augmented reality, there's so many different terms out there. You have AR and MR and XR and VR. What's what? So we're going to spend a moment and just go over some of this common terminology. Augmented reality is having and placing digital content in your physical world, right? That at its core is augmented reality. Within augmented reality, though, we have mixed reality. Mixed reality is taking that digital content and leveraging the physical world to interact with it. So what that is doing is, say I put a digital ball in a room. Now I could go flick that ball, and if it bounces off that wall, that's what we would consider mixed reality versus the ball passing through, which would be just a standardized augmented reality experience. Now, on the other end of the spectrum, we have virtual reality or VR. Now, a lot of times you'll see AR/VR in companies' product portfolios. It doesn't mean they're the same thing. It means they support two different core technologies. Now, if augmented reality and mixed reality is placing digital content in the physical world, virtual reality is the opposite. They're placing you, a digital avatar of yourself, in a virtual world. So there is no actual usage of your surrounding environment. You are being fully immersed in some created, curated, fully digital environment. What we're starting to see now with newer technologies is what we call video pass-through, and we're starting to see a trend and new use cases emerge where virtual reality is using video pass-through so you could have VR experiences that interact with your physical world. So a couch in a VR experience might not look like your couch in your room, but it's going to be part of the experience that you are in. So you'll be sitting on your couch while you're sitting on the couch in the digital environment. It just might not be the same exact couch. We're starting to see those use cases emerge. It's a very young space for video pass through in the VR world. Really interested to see where that's going to go. Since we've talked about some terminology and the definitions of augmented reality, what it is and what it isn't, we're going to spend a moment and talk about what these AR capable devices are. What types of devices do you need as an end user in order to experience augmented reality? We have three major categories. Mobile devices, we all carry them around in our pockets. These are your iPhones, your Android phones, your iPads, your Android tablets. 3D AR headsets. These are your HoloLens 2s. They are your Magic Leaps. These are more enterprise focused. Not everyone is going to have a HoloLens 2 laying around their living room. They're very pricey, and they were built and targeted for enterprise and hands-free applications. Now, these AR headsets, such as the HoloLens and the Magic Leap, support what I would call true augmented reality because it is placing 3D objects in your physical world just like the mobile devices do. Now we have this third category, 2D assisted reality. 2D assisted reality, I would not consider to be true augmented reality capabilities. Really, what that is more of a heads up display type experience. And we have some examples of that later on. But devices that would fall in this assisted reality category would be your Vuzix, your RealWears, and stuff like that. You would utilize a device or assisted reality when you don't need necessarily that full AR type of experience. You might just be displaying a couple work instructions or some type of overlay for some quick reference for that end user.
So, Brian, I think a lot of us have seen various examples of headsets in things like movies and TV shows where it seems like you can really do whatever you want with just a simple pair of glasses, especially in the 2D assisted reality space. Is that accurate, or are there some misconceptions about the capabilities of each device type?
Oh, there's definitely some misconceptions. So your most flexible device type is going to be your mobile and your 3D headsets. And by flexibility, they're going to be relatively capable of similar types of use cases. Some have more power than others, so there's some limitations there. But in general, you're going to have the most flexibility with those. But you're talking about cumbersome, low battery life, discomfort after a few hours of usage. So those types of devices, you're not going to get that spy game type experience. The reference you made to that spy film would be most similar to assisted reality glasses, but what you're not going to get with those is that face recognition box over the enemy, and it's tracking them across a lake. What you're going to do is just have that as an overlay on the screen. So as you move your head, that content is going to follow you instead of being placed in that physical world overlaid on that person that you wanted it to be on.
And one more question. In the world of headsets versus handheld devices, are there limitations from an end user perspective about which one you would use if you're, building a program or trying to employ one of these technologies? So obviously, one goes on your head, one goes in your hands. What considerations are there in choosing the physical hardware?
Yeah, great question. The first and foremost, you need to consider the end user and the use case that they're doing it. So everyone these days basically has a mobile device. So that should be the first device of interest when you're building out a new experience. You know, does the use case and the end user, are they able to get everything what they need on a mobile device, an experience delivered through a mobile device? The answer is no. For example, maybe a step-by-step work instruction that has a level of complexity where they just always need to be referencing and seeing what to do. That's where you'd want to choose a headset. So you can be hands-free. You can still deliver that AR experience to the end user in a better way. So there are reasons to pick one device over another. At Boston Engineering, we generally like to focus on the iOS devices and only move to the hands-free AR headsets when the mobile device is just not good enough for the experience that we're building. We talked about devices, so now we're going to get into some examples of assisted reality and augmented reality. Up first is assisted reality. It's 2D content, not spatially aware, limited interactions, but You get the benefit of all-day battery life. These devices require very low computational power, which allows the device to last a very long time before charging. So one thing to note in that video that's playing is that when that user is moving their head left to right, that content is staying with the user. It's not being locked into that physical world. That is what we would consider not spatially aware. While in this video, as that user is moving around, that content is being locked in. That is what we would consider spatially aware. It has a place in the physical world. The headset, the iPhone, it has built and computed a digital map of that physical space that user's in. And when that user or the experience placed that content, it said, this is your space. This is where you are going to be locked to, no differently than when you go move a chair in your apartment and you go, this chair belongs in the corner, right? Digital content has the same space ownership as the physical content in a augmented reality application. So since we are having these spatially aware experiences, there is a downside, very short battery life. These devices have high computational demands. They're computing in real time these very complex maps. I would like to generally equate them to high-end mobile games, right? You could only play a high-end mobile game for a couple hours before you need to recharge your phone. The same thing's going to happen with augmented reality experiences that take advantage of spatially aware content. You're only going to have a couple hours of battery life before you need to recharge or bring a battery pack with you.
Is there a way to blend elements of the 2D and 3D mapping in the same space? Or do you basically commit to one style of usage when you go out and build a platform?
Yeah, so you could definitely combine the 2D and the 3D elements in the same experience. You would make that decision up front when you're storyboarding out and you're doing your wireframe designs on what you'd want to do. It's actually a fairly common thing to combine the two because not everything works well in 3D. There is still a need to have that 2D informational data that stays with the user. There's been a lot of studies around what needs to be 2D and what should still be 3D. And I mean that's really changing all the time as people uncover new trends, new types of interactions, new way to interact with content. But the short answer is yes, you can combine the two. You just have to be cognizant of your target device because not all devices can support both of them together, such as an assisted reality device where you are going to be locked into 2D only, a place to live. With augmented reality, there's a number of technical capabilities. We're going to highlight three of them right now. One being visualization of 3D content. We've talked about that quite extensively so far. That is placing 3D digital models, assets in your physical world where you may or may not need to move them, interact with them, so on or so forth. The second thing is natural interaction with 3D content. And this is really one of the areas where augmented reality shines. You could not just place the 3D content and look at it. You could pick it up, you could grab it, you could throw it, depending on which type of interactions that application supports. It was asked earlier about the different devices. Why would you want to choose one over the other? Interaction is one of those examples on why you may want to choose a hands-free headset such as a HoloLens or a Magic Leap because they have really good hand tracking capabilities built into the device itself. So when that 3D cube is placed in front of you, you could go up and you could grab it with your hands without any additional controller support or hardware. Grab it, move it, feel it, throw it. Unlike a iOS device or an Android device, any mobile device, they don't have that hand tracking capabilities built in. So you are limited to 3D content interaction in a different way through generally some type of user experience or buttons and triggers that the developer might have put in place for you to interact with it. But that natural interaction comes from those hands-free devices. The third one, and this is something that you're starting to see a lot of use cases come out of, is environment scanning. Now, you could scan your environment, offload it off the device, and essentially have a 3D model of that physical space, right? That is just one use case on its own. What we're starting to see now is if you do that over a series of days, you now have a tool to do change detection for a warehouse or a logistics facility. That's not the only use case for environment scanning. A lot of these devices have built-in LiDAR on it now. So the new iOS devices have an onboard LiDAR. What that's doing is computing these 3D meshes of your physical environment in real time. So now when you place that AR content, it becomes stickier. What I mean by stickier is it doesn't lose its position in the physical world. That's easily as if it did not have this 3D mesh to attach itself to. Generally, when you create an AR experience or you join an AR experience, you use an AR experience, the devices are scanning the world in real time, creating what is called a sparse point cloud map. All it's doing is looking for key features in real time. So table corners, chair corners, texture differences on walls, things like that. And it's combining them together to build really a dotted 3D map of the physical world. When we place content in that sparse point cloud, that content we could place anywhere, but it's referencing those key feature points that the device is keeping track of, right? So you could almost imagine that if it's referencing references, it has that risk of moving because if that reference moves, your content will move. We call that drift. Now, with the advancements of LiDAR on these mobile devices, we're not just building a sparse point cloud map, but we're also using the LiDAR and generating a 3D mesh on the fly. So when I place that content, I'm placing that content at an offset XYZ location of the origin of that 3D mesh. So that mesh will not move, meaning my content has a less likely chance of moving. And those are some of the benefits that we get from this onboard environment scanning, which for the most part nowadays is happening by default as soon as you launch your AR experience.
So just to recap, for those who may not be familiar with the term itself, what is LiDAR and what does it mean in relation to AR?
LiDAR is a light sensor that basically shoots out thousands of times a second a little light, and it will run indefinitely until it hits a surface and then bounces back. What it's doing is on that bounce back, the sensor itself knows the distance of that point, and it's doing is tracking all these points and meshing it together. We could probably spend, you know, hours talking about LiDAR itself, but in its simplest form, it's a sensor built in these devices that leverages light to build a map or a dense point cloud, which is then converted into a mesh of the environment. And it's on a lot of the devices by default now. In the AR toolkits like AR Kit, AR Foundation, they are leveraging this LiDAR by default to improve the user experiences of these AR applications.
Makes sense to me.
So we talked about what is assisted reality, what is augmented reality, what are some of the technical capabilities of augmented reality. I want to spend a little bit of time talking about the user experience, because really, without a good user experience, your augmented reality application just won't be good. People won't want to use it if it's hard to use, and that, I mean, that's a common thing in any software these days. Users expect great experiences, great interactions. They want to have those good feelings when they're using your software. So visualization, shape and scale understanding. This is very important. When you are building out your AR experiences, you have to take into account the environment that user is going to be in, and the size of the content that you are placing in that world. So if you are doing, say, equipment placement checks, right? You're gonna load in a CAD model of, say, a table saw. Well, you don't want this table saw to be all tiny if the use case is to see how this table saw looks in my tool shop, right? A good example is on the Best Buy app now and the IKEA apps. You could try the furniture out virtually in your apartment before you commit to the purchase, right? Scale is very important in that scenario, because you're trying out a product. You want to see how that product looks in your home before you make that purchase. So scale, shape, very important. Interaction, natural interactions through hand and eye tracking, like we just talked about as one of the technical capabilities of doing a hands-free type experience with a HoloLens. Or are we going to do interactions through buttons, triggers, toggles, because we are building an application only for mobile devices? There's additional type of interactions, though, of not just the user interacting with the content, but the content interacting with other content, or the content interacting with the environment around itself. And that's where we start to combine interaction with that environment scanning capabilities we talked about previously. The dice down there is a really good example of that type of digital content interacting with the physical world. The user's throwing dice and it's bouncing back off the trees and it's bouncing back off of each other. So the user has interaction with the dice. The dice has interaction with the physical world and the dice itself. This bottom left-hand video is a fun one. I like it. It's a spatially aware AR experience where the user isn't actually interacting with the content. They're visualizing the content. It's almost like an animated movie that they're being a part of. Now, we're starting to see this a lot in AR storytelling. So it's how can we immerse that user in a story, in an emotion? How do we use AR to have someone feel, right? And how to make them feel what that character is feeling. And another example would be training, right? Using AR for a training. If we could immerse them in this simulated environment a little better, their retention of that topic will increase.
So, Brian, I've seen through a lot of different social media apps now, the prevalence of being able to interact with little characters that you drop onto your environment. You can scale them, but they don't seem to know that you exist or that you're there. So, how does that type of visualization compare to the dice, for example?
Yeah, so under the hood of AR, there's multiple levels of environmental understanding, environmental scanning. So far we've talked about the more complex stuff where the devices are actually generating 3D meshes and 3D maps of the physical world and attaching content to it. There's some simpler ways that the device can understand the physical world as well. And really, that is a application, use case, and design decision in the beginning. But What you were just referencing in that type of experience would be planar identification. The device is looking for flat surfaces, and when it identifies a flat surface, it allows you or automatically places the content on it. It doesn't know that flat surface is a table. It doesn't know if it's the floor. It doesn't know if it's the ceiling. It's looking for flat surfaces. Another type would be looking for vertical surfaces. It's looking, would be referencing a wall, right? But it doesn't know if it's your front wall or your back wall. You could have them both on flat and vertical surface recognition. So you could put a picture frame up and you could have that little emoji guy running around on the table. So that's one of the more simpler ways to lock digital content to the physical world, where its interaction with the environment is not as important to the experience. Now, there's even a level below that where you could just place an object in the world and it will just float in space. It might move, it might flicker, and all you're doing is saying, content, you go here. It's giving it a home in that sparse point cloud map. It's associated with a couple of key feature points, and it's just there, right? It has no recognition of flat surfaces, no recognition of vertical surfaces, no recognition of the chair that might be under it. It just knows that it's supposed to live here in space in that location in the physical world. So those are some examples of the other types of ways you could lock content to the physical world in an augmented reality application. And really, that decision on how you want to take that approach comes up front when you are doing the initial design of the application and the primary use case that you're building the application for. And actually, we have a really good example of that planar surface recognition on the next slide. Here's a demo that I really like. Eighth Wall created this for AWE 2022. Still live. I know I'm just as surprised as you are that it's still active and being supported. But if you take a moment and you scan that QR code with me, we go walk through this application together and you could see exactly how this AR not just works, but how we are identifying the surface and how we're interacting with this character that will be running around on your table. All right, everyone. So I got my app loaded. You're first going to be prompted with some permissions, very common in AR applications. Since we've talked about we're using the lens of the camera to see this content, you're going to first be asked to access the camera. So we're going to allow that. If you hit cancel, you're just not going to be able to experience that. But all we're doing is allowing the app to access the camera to turn it on, so it could be our lens. So I'm going to push allow. If there's any other permissions as well, just go ahead and accept them. We need them to experience this application. All right, great. So everyone by now should have the application with really this little square icon and a down arrow. And it's going to say tap ground to place. All right. Well, let's actually talk about what is happening right now. You're going to tap the ground to place. And as we do that, you're going to see an experience pop up on your floor or on your table. But what was happening is that device, when it said tap ground to place, was looking for flat surfaces. So when we tap the ground on a flat surface, our content appeared, right? That was a design decision by the creators. But I would like you to focus your attention on the Yeti that we have on our floor now. Now he's sitting there, he's hanging out. There's some balls that look like they are kind of interacting with each other. They look like they're interacting with the floor. In reality, they're just sitting on that flat surface. But it's a really cool experience. So how do I interact with this now? So we have content interacting with content. How does the user interact with it? For the sake of this application, they gave us a nice little instructional drag to move Captain Dottie. So if we touch the screen and we move our finger around, you see a little virtual joystick that appears. And by doing that, our Yeti can run around and kick the balls. So we are now having, through a virtual joystick, us, the end user, interacting with this digital content that is superimposed in our physical world. Now, it's not really there on the floor, but through the lens of the camera, you can see this digital content and you could experience this application, these developers and wanted us to experience.
So I noticed if you pan far enough away from where you initially dropped the Yeti, it disappears out of the view of the screen, but then when you pan back, it seems that the application remembers where you initially dropped. Can you reiterate how that process works?
Yeah, definitely. So the moment we initiated the application, it was looking for those flat surfaces to place the Yeti. In addition, though, it was building a sparse point cloud map as well. So you get the orientation of that 3D content on the planar surface and in your environment around you. So as that device moves, it's taking the IMU data off the phone, combining it with the key feature points, and really just building out this experience. So when you place that content, the application stored the origin point of that content. As you move the Yeti, the position of that Yeti and the balls and all that digital content are being updated and stored in the application. So when you pan away, the device still knows the orientation and the placement of that content in that sparse point cloud map. So as you pan away, in reality, you're just building out that point cloud map even further for the application. And then when you come back, your content's still locked there, right? So unlike assisted reality where the content follows you, it's it's where we left it in the physical world. So that's why it's still there. Now, if you took that same application and you panned and you looked around, you walked around, you came back, your content's still on the floor, get up, stand up if you put it on your floor, and have the Yeti walk around the room with you. You'll see how this Yeti will continue to move as you do it, as you're continuing to build out this map of your space. And then once you get him into a different corner, walk away again, turn around, come back, he should still be there because that position, that placement, that orientation, that reference, that point cloud map is a living thing until the application turns off.
We really appreciate you taking the time to work through an AR demo with us, Brian, and also give us a technology overview. If you have any questions for Brian or want to learn more information about this technology, you can visit boston-engineering.com or reach out to us directly at info@boston-engineering.com. Thanks, Brian, for your time.
Thank you.